So today we're going to learn about slope fields, and slope fields show the solutions to differential equations. So let me just go through this with you, okay? You're looking at, from last week when we solved differential equations and we solved particular differential equations, what we were doing was we were finding one of these. And if you see all these points, okay, those were the initial conditions that allowed us to come up with the equation for this one. So this is a visual of what we were doing the other day, okay? And so I'm going to switch over and show you what I'm talking about when I talk about a slope field. What you're seeing here is a lot of solutions. Last week we found just one of them, the particular one, but everywhere you see these dots, okay, those are particular solutions, okay? So let me go to my graphing program and I'll show you how this works. So what you're seeing here is a graph, a grid, -5 to 5 on both the X and the Y axis. And I'm going to type in my differential equation. And you don't need to know how to do this part, okay? But it's going to be y prime instead of dy over dx. And it's equal to x plus y. So that's the graph that we just looked at. All right. And what it creates is these little slopes. So what it's doing is it's taking the x and the y coordinates and putting it into the differential equation, the dy over dx, and calculating the slope and then drawing a little small slope line at each of these. So that's what you're seeing here is like right here at, let's get a nice value at, let's go here. Okay. So at 2, 2, the slope's 4. Okay, at 6, 6, the slope is, and my picture's in the way. All right, let's go over here. -5, 5, the slope is 0. Okay, and right here at -1/2, 0, or at -1, 0, the slope is -1. All right, so what you can do is like last week, okay, I gave you, here's the coordinates. All right, now plug those in and find the particular equation. Right? And so if we can do this, and I'm going to click here on some points, all right, and it will produce a line. Now that is the curve, all right? That's a particular solution that goes to the point 1, 3/2. And so we can just click a whole bunch of places, and it's showing me a lot of the different solutions, and that's what you're seeing, okay? And it's curvature, and there's almost like this diagonal asymptote right here that's happening. And we're just clicking on all of these, and you can start to see the behavior of these. So these are used in physics. You may have seen them on weather channels because they're vectors basically, okay? And so, this can show wind direction. It can show a lot of things, magnetic field lines. If you had physics last year and you guys did the magnetic stuff with Mr. Jet. Okay, so I'm just clicking on a bunch of these, right? Okay, so this is showing a bunch of solutions to it, okay? So I want to go back and then do the next part of this, and that's actually, we're going to use the slope lines to guide us to help us draw one solution, okay? So right here, we have the same, slope field that we were looking at earlier, and we want to sketch a particular solution that passes through the point 2, 0. This is sometimes asked on the AP exam, okay? So we want to draw the one solution that goes through this point right here, this point 2, 0. And so what you want to do is you want to use the slope lines to guide you. You don't want to cross them. Like I wouldn't want to draw going this way because that's going like against the grain of, or the direction of these slope lines, right? So it just has to be kind of close. Like we're kind of come up like this and then kind of come up and something like that. Now this side, it's going to start turning, right? And it's going to come along like this dashed or this diagonal line right here. So we're going to come along here. If you're going like across a slope, like in the opposite direction, okay, that tells you you're doing something wrong. So just kind of, kind of somewhere in between here. And then it's coming up. You see how I'm using the slope lines to kind of help guide me. And then it's going to come up, something like this. All right. And that's just, the general principle is just use the slope lines to guide you in your drawing it. Okay. Now, you're not going to have any homework because the homework I'm going to give you is on Delta Math. And on Delta Math, it's going to be multiple choice. where I give you a slope field and you have to figure out which of the differential equation it represents. And then we're also going to do it where we draw the slope lines, and we're going to do both of those on Delta Math. Okay. So let me go to the next one and I'll show you what I'm talking about. So now we're going to do matching the slope fields. So we have 4 differential equations and we have 4 graphs, and we're going to match them. Okay. Very similar to what you're going to do on Delta Math, but I'm going to grab a couple problems on Delta Math to help us understand this. Okay. So some things to think about. Okay. We want to consider a few things when, and let me write this. There's not one way to do this. Okay. But we want to consider when is dy over dx equal to 0, okay? Because if dy over dx is equal to 0, that's going to cause horizontal tangents. And so our slope lines are going to be horizontal, okay? So we'll have horizontal slope lines, okay? We also want to consider when is dy over dx undefined. Because when it's undefined, we're going to have vertical tangents. So we're going to have vertical slope lines. And those are pretty easy to spot. Okay, another one to look at is, okay, so when does dy over dx equal 1? So this is like, these are the go-to ones. And then this is, you might want to consider this. Okay, when is dy over dx equal to 1? So what causes the numerator and denominator to be 1 or anything like that, okay? All right, because this would have a nice positive slope. Another one is dy over dx is equal to -1. And then one other scenario is take a number and just plug it in. Take a point and plug in. So plug in x comma y and see if it works. Okay, so that would eliminate, like, if you're supposed to have a positive slope and you have a negative slope at that, you know it can't be that slope field. Okay. All right. So like looking at this first one. Okay. So we're looking at these. Okay. So this one, you can kind of see there are horizontal slope lines on the x-axis. All right. And then there's vertical slope lines on the y-axis. So on the y-axis, that's when x equals 0. And on the x-axis, that's the y coordinate is going to be 0. All right. And then over here, it looks like we have horizontal ones on the x and also on the y-axis. Okay. And then over here, horizontal, looks like we have like horizontal like at 1, 1, 2, 2, 3, 3. And then over here, I don't see any vertical ones on this one. And then horizontal ones, I see horizontal ones right on top of the y-axis, and I see vertical ones on the x-axis. Okay. So, all right, so let's go to, okay, let's consider when does dy over dx equal 0. So for this one, when does dy over dx equal 0, right? That would be where x minus y is equal to 0. Okay, so that'd be where x equals y. So we'd have horizontal slope lines, all right, at every point where the x and the y coordinate are the same. So that would be like 1, 1, right? So you look right here, 1, 1, we should have a horizontal slope line right there, right? That's what this is telling me. We don't. Okay, so this one is not this differential equation. How about 1, 1 here? At 1, 1 here, nope, that's not horizontal. So it's not that one. At 1, 1 here, yeah, that's horizontal. Okay, so it could be this one. And let's keep looking. Okay, at 1, 1. Okay, no, 1, 1, it's not horizontal, right? So this one right here, this slope field has to be the dy over dx is equal to x minus y. So we've gotten that one, okay? So now, how about this one? Okay, so when would this be 0? Okay, so dy over dx equal to 0. Well, that would be where x times y is equal to 0. Well, that'd be when x equals 0 or when y equals 0, right? So on the y-axis, okay, that's where x equals 0 because x equals 0. Okay, if we look at this one, they're not horizontal, right? They're vertical. So it can't be this one. And you look right here, okay, they're horizontal here, right? When x equals 0, they're horizontal. and they're horizontal here, this would be on the y-axis. This is where y equals 0, and this is where x equals 0. And so you look, okay, yeah, it could be that one, right? Well, could it be this one? Well, all right, they both, when x is 0 or when y is equal to 0, we're going to have horizontal. So we have horizontal when x equals 0, right? Because right here, x equals 0. But when y equals 0, that's the x-axis, we don't have horizontal, right? We have vertical. So that means it's going to have to be this one, right? So this one right here is dy over dx is equal to x times y. All right, how about this one? Okay, so dy over dx, when does it equal 0? Okay, so that would be where x over y is equal to 0. Well, for this one, okay, it's going to equal 0 when x equals 0. So when x equals 0, we're going to have horizontal tangents. All right, but we have a fraction here, right? So we could also consider when is dy over dx undefined. And that's when the y is equal to 0. And that would be vertical. So when y equals 0, we're going to have vertical tangents. Okay, and what is y equals 0? Y equals 0 is the x-axis. Okay, so if we look at the x-axis, we should be seeing vertical. Okay, so x-axis, no, not vertical. X-axis, vertical, right here, right? And so we also see, okay, this is going to be when x equals 0, that's the y-axis. I know it's kind of weird. When x equals 0, it's the y-axis, but that's true. When x equals 0, you're on the y-axis. So on the y-axis, we'd be horizontal, right? So if you look right here, the y-axis, we have horizontal, but on the x-axis, we have vertical. Okay, so that's this one. So this one is dy over dx is equal to x over y. And these are similar to the ones I do in the book, okay? But this is just getting us there, you know, to help us figure out what they are, okay? And a lot of times they do ask the multiple choice questions. So I think Delta Math is really going to help us really fine tune this and get it right, okay? So dy over dx here, okay, when would it equal 0? Okay, that would be when the numerator is 0, right? That's when y equals 0. So y equals 0 is the x-axis, and so we'd have horizontal on the x-axis, basically, is what it's saying. And then when is dy over dx undefined? That's when the denominator, is going to be 0. And so when x equals 0, that's the y-axis. And so we'd have vertical on the y-axis. So we're going to have vertical slopes on the y-axis and horizontal on the x-axis. And we only have one left, right? I know like by default, it has to be this one, right? But we still need to go through this analysis because, like, you know, we're not always going to have, you know, the last one has to be the last difference equation. We're not always going to have that, all right? So right here, if you look at this, okay, so the x-axis, we should see horizontals, yes. And on the y-axis, we should see vertical, and we do see those, right? Now, this is what I was talking about earlier. If we let x and y both be 5, right, that would be the point right here, right? This would be the point 5, 5. And 5 over 5 would be a slope of 1, and that looks like a slope of 1, okay? So at 5, 5, dy over dx is equal to 1. So if you put 5 over 5 and you wound up with -1, right? And you know you did your calculation right, and this came out, you know it couldn't be this one. That's what I'm trying to get across, okay? So that's a last ditch effort, is to just start plugging some numbers in and see which one gives you, it might be, you know, like on a multiple choice, it might eliminate what some of the possible ones could be, okay? And then you narrow it down to the only one it could be, all right? So you eliminate possibilities, basically. Okay, all right, I'm gonna go to Delta Math and we're gonna look at a problem, okay? Okay, so for this one, we're select the difference equation that matches the given slope field. So here's our slope field, okay? And we're looking at, we see horizontal tangents on the x-axis, okay? And on the x-axis, y equals 0. I'm gonna try to annotate this. We'll see how this works, okay? So when y equals 0, 0, all right, when y equals 0, we're seeing horizontal tangents. So we should see little horizontal slope lines, okay? And then what else? Okay, so when x equals 4, right in here, when x equals 4, we're seeing vertical. So x equals 4 vertical tangents. Okay, so that means y equals 0 horizontal tangents. That means if we put y equals 0 into our equation, we should get 0 out of it, right? If we put y equals 0 or into this first selection, it would cause it to be 0. Same thing with the second selection. Same thing with the third selection. Okay, if we put it into the fourth selection right here, this last one, okay, that would cause it to be undefined, right? If y was equals 0, that would cause it to be undefined. So that would mean we would be seeing vertical slope lines on the x-axis, and we're not, right? So we've already eliminated the last potential one, right? Okay, so then, all right, so then we have vertical tangents, right? That's where it'd be undefined at x equals 4. Right here at x equals 4, this one is undefined. So that's not going to help me, right? So I'm going to have to try something else. What happens when we plug in, let's say like 2, 2, okay? So 2, 2, if we put it into this one, all right, and I'm not going to be able to, if we put it into the top one, right, we're going to get negative, and 2 squared would be 4, divided by, and you know what, I should put 2, 2. I'm checking the point 2, 2. Okay, so in the top here, I'd get 2 squared, which is 4, but this is going to make it negative 4. And then down the bottom, I'd have 2 minus 4, which would be negative 2 squared would be 4. Okay, so at 2, 2, this is what I mean by plugging that point. At 2, 2, we have a slope of negative 4, right? So guess what? We've just eliminated this one. So now we know it's one of these two, okay? So now let's try 2, 2 in the second one, okay? So if we put it in here, this would, if we try 2, 2 again, we would get negative 2. And then divided by, okay? And then this would be 2 minus 4, which would be negative 2. And so we have negative 2 over negative 2, which is positive 1. Okay, so it could be this one, right? All right, and then so now let's go to this one. How about 2, 2 here? Well, at 2, 2 there, that'd be 2 squared, which is 4. Okay, so that'd be negative 4. Well, sorry, yeah, negative 4 divided by, and then this one right here would be 2 minus 4, and 2 minus 4 would be negative. 2 minus 4 would be negative 2. So that would give us a slope of positive 2, right? So maybe, right, so we've eliminated this one, right? Now we're down to these two. So now we got to try maybe another point, because that really didn't, because we're going to get a positive slope with this one, and we're going to get a positive slope with this one, right? So let's go to another point. Let's put in, and it's just really picking. Let's put in, heck, let's put in 0. Let's put in 0, 3. Okay, so what happens when you put it into, because we've narrowed it down to these two, what happens when you put 3 in for y? So that would be negative 3 divided by, and then 0 minus 4 would be negative 4, right? So 0, 3, we should have a positive slope right here, right? And we do. Okay, so how about the next one? Okay, so how about this one? What if we put it in here? All right, so if we put 3 in here, that'd be negative 9, and then divided by, and then through 0 minus 4, and that'd be negative 4. And that would give us a positive slope too. And we have, so that didn't help, right? That didn't help at all. So I think it's easier to write on this. I was trying to do Delta Math and I just can't write on Delta Math. And I just think it's easier. So I copied one from Delta Math and we're going to use this one. Okay. A little different than what I anticipated on this video. So sorry about that. Okay. So the process is going to be this. All right. So we look right here and there's horizontal tangents, right? So that means when we plug in y equals 0, okay, when y equals 0, we're going to get horizontal line segments, so horizontal tangents. Okay, and then we're looking for vertical slope lines. So right here, right at x equals 4, we have vertical slope lines. Or vertical tangents. Okay, now that's only going to happen when dy over dx is undefined. So that means if we put 4 into the denominator, that's going to cause the denominator to be 0. Okay, so like that works here, right? 4 minus 4, that's going to, so it could be this one, it could be this one, it could be this one. It can't be this one, right? What's going to cause vertical tangents here is when y equals 0. So if y equals 0, that's this, the x-axis. So if it was this one, we should be seeing vertical tangents along the x-axis, and we're not seeing that. We're seeing horizontal ones, right? So we can eliminate this one. Okay, so it can't be that one. All right. Now let's start looking at some other things. Okay, so when y equals 0, okay, that's going to cause this one to be horizontal. It's going to cause this one to be 0, you know, and this one's 0. So that's not going to help, but we've narrowed it down to 3 of them, right? So let's take a look. What about at something like the 0.22? Okay, so here's where you start, you know, putting some points in. Okay, so the 0.22. So if we put 2 in here, this would make negative, and this would be 2 squared, which would be 4, over, and then the x is 2, so 2 minus 4 is negative 2, squared is 4. Okay, so at 2, we should be seeing a negative 1 slope. So 2, okay, so right here, 2, we're not seeing a negative slope, right? So guess what? That means this one right here that we put the 2 in, it won't work. Okay, so we've eliminated that one now. Okay, so now we have down to these two. Now, what are the difference between these? It's when y would be negative. Okay, so if y is negative here, that's going to make this positive, right? But if y is negative here, we're going to square it, which makes it positive and negative. So what we're going to look at, let's pick a point where we have an x coordinate and an x coordinate that's bigger than 4, okay, and a y coordinate that's like a negative value. Okay, so let's say like something like 6, -2. So let's do 6, -2. So if we put that into here, okay, this is going to be -2, but we're going to take the negative of it, so it's going to be +2 over, and we put 6 in here, so 6 minus 4, that'd be 2. So at 6, -2, 6, -2, we should be in a slope of 1. We're not seeing a slope, right? We're seeing a negative slope. So we've eliminated this one. Okay. Now let's just confirm this one to make sure we didn't make a mistake. So if we put 6, -2 in here, we're going to put -2 in here, which we're going to square it, which would make it 4. And then we're going to take the negative of it. So this would be -4 over, and then let's put 6 in. So 6 minus 4, right, is 2. So this would give us a slope of -2. Okay, yeah, that could be a slope of negative, right? We just know that the slope is negative here, right? So that's it right there. So this is our answer right here. Okay, and so you'd select that one and click on submit. Sorry, I can't do this. I think I need to write this so you can see the explanation part of it too. Okay. All right, let's do another one of these. All right, looking at one more of these. Okay. You're looking for horizontal tangents. So right here where y equals 1, okay, that's going to cause dy over dx to equal 0, okay, because horizontal tangents cause dy over dx to equal 0. And then, all right, so that's the only place we see horizontal tangents. But then right here, right here at x equals 4, we see vertical tangents, right? So at x equals 4 right here, dy over dx is undefined. How do I know that? Because that's what causes vertical tangents, okay? All right, so that means this 4, if we put it in the denominator, it causes it to be 0. Okay, so that's not the case here, right? We would be putting 1 in. And so this is saying if we put y equals 1 in, that we should have vertical tangents at y equals 1. We don't, we have horizontal, right? So this one's eliminated, okay? This one right here, we don't have a denominator, right? So we're never going to have where dy over dx is undefined. So we actually have eliminated this one too. Okay. Now we got to look at some features of this. Okay. So what's the difference between these? The only difference between these is both of these are squared. And what happens when you square a number? Well, it becomes positive, right? So the numerator, this numerator is always positive. And the denominator would also always be positive. Okay, so what does that mean? That means your slopes are always going to be positive. Okay, now it could be 0, but they're never going to be negative. They're never going to be negative. And if you look right in here, we have some slopes, right, that are negative. Well, it can't be this one then, because when you square these, it's gonna cause it to be either 0 or positive. It will never be negative. Okay, so just to confirm, let's pick a point, okay, and let's just make sure, especially like over here, all right, let's pick let's say -6, 6. So when x is -6 and y is 6, or yeah, let's do that. Let's do -6, +6, okay? So when we put y is 6 in here, that'd be 6 minus 1 over, and then this would be -6 minus 4. That would be 5 over -10. Okay, that would give me a slope of -1/2. Yeah, that kind of looks like a slope of -1/2 right here at this point, right? All right, and that's the idea behind this is you got to use a lot of different things. I mean, start out looking for the horizontal and vertical, and then, you know, look at the features of the differential equation, and then also, you know, you got to think a little bit, all right, and kind of strategize, okay, what would cause this to happen? And then just start plugging numbers in, okay? And I would always plug a number in just to confirm it, okay? Like I've narrowed it down, like I should have crossed this one out. Like we narrowed it down, it can't be these 3, we pick that one, right? And then check it, okay? All right, so we're gonna do this next one the old school way, right, by hand, okay? So we wanna construct a slope field for dy over dx is equal to x over y plus 2. I've seen this on the AP exam, okay? And it's all relative, and you'll see Delta Math is gonna require you to draw the slopes relative to other ones, like steeper and less steep and all that, okay? So basically we wanna take these points, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, these 12 points, put them into the derivative, all right, and see what happens, okay? Now, some of them we can do right away, okay? When x equals 0, okay, that's going to cause the slope to be 0, right? So right off the get-go, dy over dx at let's say, let's just do these right here at 0, 2, and dy over dx at 0, 1, and dy over dx at 0, 0, and then dy over dx at, and then 0, -1. Okay, so take a look what's going to happen here. Okay, so we're going to have 0 over, and my y is 2, so it's going to be 2 plus 2, which is 4. That's still going to be 0, right? So right here at 0, 2, we're going to draw a horizontal slope line. So just a really short one, like that, okay? And then at 0, 1, okay, the top is going to be 0, and the bottom is going to be 1 plus 2, which is 3. So that's going to be 0. So 0, 1, it's going to be horizontal. So I'm using these 2 lines or another point to help me draw it, okay? And then at 0, 0, that'd be 0 over 0 plus 2, which would be 2. That's still 0. So that's what's nice about these. These are all going to be horizontal, right? And you can even tell this one's going to be 0, 2, right? So this is going to be 0 over -1 plus 2, which would be 1, which is 0. So even this one is. Okay, so when they grade this would be on a free response. Okay, when they grade this, they're looking to see, do you have all 4 of these as being horizontal? Okay. Now let's take a look what happens as we go down here. Okay. So now let's do this. Let's do this one right first. Okay. So we're going to take a look at what is dy over dx at the point 1, 2, dy over dx at the point 1, 1, dy over dx at the point 1, 0, and then dy over dx at the point 1, -1. Okay, and let's try to do this in our head. Okay, so x is going to be 1. So actually on all of these, the numerator is going to be 1. Right? So what's the denominator going to be? It's going to be y plus 2. So this one's going to be 4. This one's going to be 3. This one's going to be 2. And this one's going to be 1. Okay, so notice this has a slope of 1, right? So we need to be a slope of 1, we go up 1 and right 1, right? So we're going to go up 1 and right 1. And that I'm going to just draw another point that'd be right about there just to ballpark it and get an idea of what the slope's going to be. So right there, that's that one. Okay. Then at 1, 0, its slope is 1/2. So I'd go up 1 and over 2. So I'm kind of eyeballing it to get an idea. So right about there. And so that, draw that one. And then this one's 1/3. Okay. So at 1, 1, it's 1/3. So up 1 and then right 3, 1, 2, 3, somewhere out in here. It doesn't have to be perfect. Okay. But what you have to see is as you go up, they're all positive, but they're getting less and less steep. Okay. Now, another way, because I'm going to run out of paper over here, right? Another way is to go back and we could go -1 over -4. So down 1 and left 4. 1. So 1, down 1, 1, 2, 3, 4, somewhere over there. And so what they're looking for is that as you go down, they're getting steeper and steeper and steeper. They're all positive, and as you go down, they're getting steeper. And this would be the steepest one right here. Okay, so they're looking for that relativeness. Okay, it doesn't have to be perfect slope. All right, we're ballparking it, right? Okay, so then we do the same thing over here. Okay, so dy over dx at the point -1, 2, dy over dx at the point -1, 1, dy over dx at the point -1, 0, and then dy over dx at the point -1, -1. Okay, so what do I know about all of these? All of these, the numerator, because the numerator is x, is just going to be -1. Okay, what's the denominator? The denominator is going to be y plus 2. So 2 plus 2, that'd be 4. 1 plus 2 is 3. 0 plus 2 is 2. And -1 plus 2 is 1. Okay, so at -1, 1, this one's going to have a slope of -1, right? So once again, you got to be kind of parallel to this right here, because that would be going through these would be a slope of 1. Okay. And so we're going to draw that. Okay. And then we're going to go down 1 and right 2. Okay. So we could line these 2 points up and draw that one. And then right here at the point -1, 1, we're going to go down 1 and right 3. So down 1 and right 3, 1, 2. We already have that point right about there, right? So I'm going to line that one up with a ruler. And then -1, 4. So -1 and then over 4. 1, 2, 3, 4, right about there. And again, what they're going to be looking for and grade you on, okay, are all of these negative? And as you look down, are they getting more steep? negatively, right? So this one's the least steep and this one's going to be the most steep, and that's what you should see. In between here, sometimes it's kind of hard, okay? So what's great about Delta Math, we're going to do one like this on Delta Math, and you're going to, it's kind of cool. You manipulate these. So all the slope lines are there, and you're just going to tilt these up and down depending on, is it a big slope or a little slope, okay? So we're going to go to Delta Math. I'm going to write down the differential equation that we're going to do, and then we're going to calculate like we did down here, all the points. And then what we're going to do is go back, and then we'll tweak our slope field, okay? All right, so here's our slope field, okay? So they're already kind of drawn all with kind of a slope of 1, all right? And so here's our differential equation, and I'm going to write that down. So our differential equation is dy over dx is equal to negative, and the numerator is a parenthesis, y plus 1 squared over x squared. Okay, and we want to do the points at, I'm looking at this, it's 0, 0, and then 1, 0, 2, 0, and then 1, negative 1, and then 2, negative 1, and then negative 2, sorry, 0, negative 2 rather, 0, negative 2, and then 1, negative 2, and then 2, negative 2. Okay, so I'm gonna leave Delta Math, and I'm gonna calculate these, and then we'll come back. Okay, we'll calculate these, and we'll come back and we'll tweak these. All right. Okay, so we're gonna do dy over dx at 0, 0, and that would equal. Okay, so we're gonna have a negative, and then when we put y in here, right, 0 plus 1, that'd be 1 squared, that'd be 1 over, and we put 0 in here, 0 squared, right? So that makes this undefined, right? So that's going to make this be vertical, right? A vertical tangent, okay? So then dy dx at the point 0, negative 2, that would equal negative, and this would be negative 2 plus 1, which is negative 1, squared is 1. But then this, when we square 0, it's still going to be 0. That's going to be undefined. Okay, so these are both going to be drawn vertical, right? Vertical tangents. Okay, now the point 1, 0. So dy over dx at the point 1, 0. Okay, so that's going to be negative from that negative right there. 0 plus 1 is 1, squared is 1, over 1 squared would be 1, so that'd be negative 1. So we're going to need to draw a slope of negative 1 for that point. And then 1, negative 1. Okay, so we're going to put, we have a negative, and then when we put y is negative 1, that's going to cause it to be 0 squared, right? Which would be 0 over, and then 1 squared, which is 1. Well, that would be 0. So this one's going to be horizontal. And then at 1, negative 2, so dy over dx at the point 1, comma, negative 2. So we have a negative. When we put negative 2 in here, that'd be negative 2 plus 1. And negative 2 plus 1 is negative 1. And squared is 1. Sorry, I'm thinking ahead already. And then 1 squared, right? So this would be have a slope of negative 1 also. Okay, and then we need to do these three. So then dy over dx at the point 2, 0. Okay, so that would be negative, and I'm going to put 0 in for y, so that'd be 1 squared, which would be 1, over 2 squared, which is 4. So that's negative 1/4. Okay, so that's not very steep. And then dy over dx at the point 2, negative 1. And this one's going to be 4 also, right, for the denominator. And I should have put a negative right here. Okay, so negative. And then we're going to put negative 1 in. So negative 1 plus 1 is 0. So 0 squared is 0, right? And so that's going to be negative, right? I can't see it because I made that fraction bar a little bit longer. Okay. So this should be equal to 0, which means we're going to draw a horizontal there. All right. And then dy over dx at the point 2 comma negative 2. Okay. So when we put negative 2, we're getting negative 1 in the top, squared is positive 1. So negative 1 over, and we put 2 in the bottom, that's going to give us 4. So both of these are negative 1/4. All right. So we're going to go back and we're going to put these in, and we need to make these kind of close to being negative 1/4. It's going to be they got to be negative, and they're not going down very much. Okay. So let's go back and put these in. Okay. Okay. So this point right here at 0, 0, we said it was vertical. So what you do is you grab this pink point and you can just rotate it around, and there's our vertical. Okay. And then there was another vertical right here. Okay. And then at 1, -1, this one was horizontal. So we're going to make sure we draw these horizontal. So right there, it kind of clicks in too. You can't feel it, but you can see it like click right there, right? Okay. And then, okay, so then at 1, 0, which is this point, is at -1. So right now, this looks like a slope of 1. So we need to be going down, like you can kind of feel it click right there. And then this one right here at 1, -2 is also -1. So right about there. Now, these two right here are -1, both -1/4. So we got to do it really shallow. So barely, like probably right about there. And then same thing with this one, -1/4. So it's got to be down and just barely. Okay. All right. Let's see how we did. All right. So I'm going to hit submit. This is nerve-wracking for me. Okay. So here we go. Are you sure? Yes, I'm sure. And we got it right. But look, okay, so it's a little bit off, and but it's pretty close, right? These two are a little bit off. It doesn't have to be perfect. And it can show you the calculation. That's kind of nice. It shows you what you should have gotten for your calculations, right? So -1/4, 0. I always worry because I go kind of fast and because you do kind of need to go fast when you're calculating these, right? And so I'm always worried like I made a mistake in my calculations. Okay. So this is pretty cool. Like this is the first time I'm using this. All right. And I'm going to tell you, I think Delta Math is really helping us do calculus well. Okay. Because I'm looking at the test and grading it, and you guys are doing quite well. All right. All right, guys. That's it for today. That was a little bit long. Sorry. It's because of all this technology stuff that I had to show you. Okay. You guys have a great day.